Good morning everybody, myself Professor Pushpa N. Avanti. In today's video, I am going to discussing about condition for achromatism of two thin lenses in contact and achromatism of two thin lenses separated by a distance. In last video, we have discussed about the that's a circle of least confusion and also the derivation d is equals to 1 by 2 g omega. See, an achromat is nothing but an chromatic lens, or achromat is a lens that is designed to limit the effects of chromatic and spherical aberration. And a chromatic aberration, also called as achromatism or chromatic distortion, and this chromatic distortion is nothing but it is a distortion of colors. So now we have to discuss about the minimizing chromatic aberration in lens, that is the condition for achromatism of two lenses placed in contact, that is calculus method. An achromat is made by placing in contact lenses of different materials and of different focal lengths, such that the focal length of the combination is the same for both the extreme colors. It means that the focal length of the achromat is independent of the refractive index. So here now we have to consider let convex lens and concave lens. Here we have considered two lenses. In first video I told you a single lens cannot minimize the aberration or chromatic aberration. So we have to minimize the aberration. We have to combine the suitable combination of the two lenses of the different materials. That is the types of the two different types of the lenses of the different materials. That is the concave and convex lens. Now we have to take on the concave and the convex lens. That is the convex lens is made up of crown glass and a concave lens is made up of flint glass. Both are placed in a contact, and these these combination acts as achromatic combination, and let mu b, mu and mu r and mu b dash, mu dash and mu r dash represents the refractive indices for blue, yellow and red rays of light of the two material of the lenses, and fb, fr and fd dash, fr dash are corresponding focal length of the two lenses, and omega dash are the dispersive power of the crown and flint glass respectively, and let r1 and r2 be the radii of curvature of the crown glass lens, and r1 dash and r2 dash be the radii of curvature of the flint glass lens. See here, using lens maker formula we can write for the crown glass lens on 1 by fv, f1 is equals to mu minus 1 by r1 minus 1 by r2, that is 1 by, after simply make it 1 by r1 minus 1 by r2 equals to, then it becomes 1 by f into mu minus 1. So this is the general equation. Now we have to apply this equation for red, yellow and blue ray. So similarly the equations becomes, for yellow it becomes 1 by r1 minus 1 by r2 equals to 1 by f mu minus 1. Similarly 1 by r minus 1 by r2 is equals to mu r minus 1 divided by f into mu r minus 1. So then similarly 1 by r1 minus 1 by r2 is equals to mu b minus 1 divided by mu b minus f into mu b minus 1. Now we have to using the same lens maker formula for flint glass also. So then the expression for the flint glass for different colors of the rays are like this. And next, now we have to differentiating the above expression, that is df by f square is equals to d mu into 1 by r1 minus 1 by r2, or df by f square is equals to d mu into 1 by r1 minus 1 by r2, or we can take d mu divided by f into 1 mu minus 1. because here 1 by r1 minus 1 by r2, according to lens maker's formula, f is equals to mu into 1 by r1 minus mu minus 1 into 1 by r1 minus 1 by r2. Make it mu minus 1, then it becomes 1 divided by f into, that's it, then it becomes f is equals to mu minus 1. Therefore now we know that for dispersive power of the red and blue rays, then it becomes mu b minus mu a divided by mu minus 1 is equals to omega, and that this is for the crown glass and this is for the flint glass. Therefore omega f by plus omega dash by f dash is equals to 0. Now we have to substituting these equations in above expressions in above equation, then it becomes omega by f plus omega dash by f dash is equals to 0, then omega by f is equals to minus omega dash by f dash, or as we know that minus df by f is equals to d mu divided by mu minus 1 into omega equals to omega, because here 1 d mu divided by mu minus 1 is dispersive power of the dispersive power, or we can take minus that is the dispersive power omega is equals to minus df by f. So mean minus df by f is equals to omega, because the value of d mu divided by mu minus 1 is omega. So let f and f dash be the focal length of the constituent lenses, and omega dash be the respective dispersive power of the material, and f is nothing but it's a mean focal length or the focal length of the combination. Then it becomes 1 by f is equals to 1 by f plus f dash. F is the focal length of the crown glass and f dash is the focal length of the flint glass. And differentiating this equation, so we will get like this, and rearranging the terms, so then it becomes as we know that omega is equals to minus df by f. So here 1 divided by f into omega plus 1 divided by f dash into omega dash. Therefore minus df by f is equals to omega by f plus omega dash by f dash, or f by f dash is equals to minus omega by omega dash, or make it f dash is equals to f dash is equals to omega dash divided by omega. So the condition for two thin lenses are in contact are the dispersive power of the lenses should have the same ratio as their focal length, because here the dispersive power of the material is having the same as well as their focal ratio of their focal length is also same. So since omega and omega dash means the dispersive power of the crown glass and flint glass are positive quantities, f dash is negative if f is positive. Therefore here both lenses should have a different, means here omega and omega dash are positive quantities, f dash and f and f dash must have opposite signs. It means that one lens must be concave and another lens must be convex. So if the two lenses are made of the same material, that is omega equals to omega dash, so then it becomes focal length is infinity. It means that the combination acts not as a lens but as a plain glass sheet. Therefore the two lenses should be of different materials, and the convex should be made of material a smaller dispersive power if the lens combination is to acts as converging system. The dispersive power of crown glass is similar than that of the flint glass. Therefore a convex lens of a crown glass in contact with the convex lens of flint glass is used to make an achromatic doublet. So now we have to discuss achromatism of two thin lenses separated by a distance. See, consider L1 and L2 are the two lenses are made up of convex, the two convex lenses separated by the distance A, so that they acts as achromatic combination. Let the two lenses are made up of the same material and hence their dispersive power is also same. If here we have to taken f is the combined focal length of the two thin lenses, then 1 by f is equals to 1 by f1 plus 1 by f2 is equals to minus a divided by f1 into f2. And differentiating this one, we get d into 1 by f is equals to d of 1 by f1 plus d of 1 by f2 minus d of a by f1 into f2. So as we know that d of a by f1 is nothing but it is omega 1 by f and omega 2 by f. For an achromatic combination, the focal length or 1 by f should not change with color. That is d of 1 by f is equals to 0. When two lenses are made of the same material, then omega 1 is equals to omega 2. Then the distance between the two lenses becomes the mean of the focal length of the two lenses. That is A is equals to f1 plus f2 divided by 2. Thus, the separation between the two lenses must be equal to the mean focal length of the two lenses. Thank you.